Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Angie Reed and Dan Kusnierz, who both work for the Penobscot Nation in their Water Resources Department. I had the good fortune to meet Dan and Angie shortly after the Discovery Museum opened our new water exhibit focusing on the Penobscot River watershed. And although neither Angie nor Dan are enrolled tribal citizens, they have both worked for the tribe for years, and they have a wealth of knowledge about the Penobscot River and its watershed from the perspective of water quality, and we wanted to talk about how we could incorporate that into the exhibit. That led to this conversation, which was recorded in May 2024. I hope you enjoy it as much as I did. Today's episode of the Maine Science Podcast is brought to you by Bangor Savings Bank, committed to supporting scientific exploration and discovery in Maine. Dan and Angie, welcome to the Maine Science Podcast. I am over the moon that we get to talk. I have not had the opportunity to talk to river folks yet. So this is how I think of you both. You can correct me if I'm wrong after that, but that's how I think of you both, probably because we met talking about our new river exhibit. So before we dive into the cool water river stuff that you do, I want to give you both an opportunity, and I'm just going to randomly pick one of you to start, to let me know how you got into water resources and water science. And Dan, my random pick is you because Angie pointed at you first.
Works for me. Just science in general. I would say my grandfather probably has a lot to do with it. I always spent a lot of time in the woods, and on the waters with my uncles and my grandfather, my dad. It was just a huge part of our life. But when I was out with my grandfather, he took a lot of time to just take in what was going on around him and taught me a lot about just interesting stuff, like turning over rocks and looking at caddisflies and what kind of mushroom is this growing under here, and identifying plants and eating all kinds of wild stuff, in the woods. And he just kind of stirred that fascination or curiosity in me to really recognize what was going on around me and how complex and just how cool everything was. And so going through life, like originally I planned on going into like sports medicine or becoming a veterinarian. And eventually I just was out on a fishing trip in Maine and said, this is what I want to do. Like, I want to be out enjoying the outdoors and understanding how all this stuff fits together. So it really kind of stemmed, I think, from there, because I've always just I wanted to know how things worked, not mechanical things, but like living biological things. And like water always fascinated me because it's like, today I can fish wade in it. And then in a few months, I'll be standing and walking on top of it. It's the same material. How does that change, And that fact that fish can live in the water in the wintertime, that it's not frozen solid. So that's kind of where a lot of that fascination came from. And originally I was in wildlife, went to the University of Vermont and got a degree in wildlife management, did a lot of work in waterfowl research all around North America, and then came back and worked on a master's degree here at Maine. And while I was there, I got to know my predecessor who worked for the tribe, got to know what she was doing. And she left the position to take another job someplace else. And the position opened up, and I said, hey, I'm going to apply for that. That was in 93, so I've been here ever since.
Whoa, that's great. Before we go to Angie, I'm curious, how many years did you get to do these kind of exploratory searches with your grandfather?
Let's see. Ever since I was really, really young, like kind of a toddler. And then up until he was, I think, 85, I was an adult, had two boys of my own. He would still come with us on camping trips up here in Maine and camp out on an island and go fishing. So I'm going to say probably 40 years.
That's a lot longer than I was thinking. What a gift.
Yeah.
Angie, how about you? How did you get into the world of science?
Well, I actually used to think I wanted to be an architect when I first got out of high school. And then, as I jokingly say, hopefully it won't offend any architects, I met a lot of architects and I decided this is not what I wanted to do. I love buildings. So then I thought, so I changed my major a couple of times in school. Then I thought maybe I want to build buildings, right? Design the sort of structural engineering part of it. And it was back in the day when there weren't a lot of women in engineering classes. And furthermore, I was like, I really actually think the planet needs a lot more buildings. So I was like, okay, well, maybe I need to rethink it again. And these are actually, interestingly enough, some pretty traumatic experiences when you think, I really know what I want to do. And then that all shifts. It's kind of life upending sometimes. So in retrospect, I often think about, where I lived in New Hampshire, I used to take walks on this old logging road across the street from my house. Hadn't been logged in a really long time, but every once in a while I would go over this one little stream and there was a culvert going under the road. And I'll never forget, I can still see exactly where this stream is. And it was plugged up with leaves. And I would clean out the leaves from the top of the culvert. And then I would upstream of the culvert, go down and make sure it actually came out the other end. That was at this point in time, right? There was just a real connection with nature at some very, very inherent level. My mom was a single mom, so she raised me by herself, but she always made sure I went to like brownies and Girl Scouts, and I went to the Y camp many times every summer. So I got to go on a lot of trips like that. But I also spent a significant amount of time alone in the woods, going down and shoveling off the pond about a mile down this old logging road and skating around by myself or skiing or walking with the dogs. I was often in the woods alone. I'm an only child. So I think that had a lot to do with just where there was something there that even if you don't really quite understand it at the moment, I eventually found it. So I eventually got an undergraduate degree in water resources management with a minor in wildlife management. And then went on to graduate school. Didn't think I actually wanted to go to graduate school, but did some work in Puerto Rico for a summer after my undergraduate degree and found my to-be advisor at that point in time and decided I'll give this a try. So I actually worked on freshwater shrimp in tropical rainforest streams of Puerto Rico. So a lot of fun. I just love being in, on, around rivers. It's a very connected feeling. And I absolutely love protecting them and figuring out not just Western science ways that rivers behave and live, but any kind of aspect of rivers, because there's just so much to them, right? And sort of dissecting them, if you will, and breaking them down like Western science often does, doesn't always get at what the meaning of it all is. But science in many ways is, I love data. As Dan likes to tease me about, I use a piece of software to write computer code. And I've told this many times. Dan has said to me, I will probably get R to make a cup of coffee for me. So I love writing code and I love dealing with data. So there's all kinds of different data. That's one of the most cool things about science.
Yeah, and I appreciate you specifying Western science. We actually just had an event this weekend, and one of the things that came out of it is recognition that we have siloed science, not just from the rest of culture, but from each other. And interdisciplinary work is critical and vital. And I think one of the things that we can learn from who I consider the people who've been scientists for thousands and thousands of years based on observation and what they figured out, is we can figure out how to make that interdisciplinary work come back and help us kind of get the best of both worlds in that way. The rest of what you said, Angie, is a totally great, phenomenal segue into the work that you both do. I am working under the assumption that you and Dan work together a lot, partly because that's how I met you, but also just based on, your background and your bios. So I think what I'd like to know is, as a water resources planner, Angie, what you do, and then as water resources program manager, Dan, what you do for the Penobscot Nation, and kind of where you guys intersect, where you don't, and then maybe where your expertise and work may even go beyond just the nation itself.
I think Dan can go first. He's been here longer and had a sense of what the program was doing before me and how I fit into it when I got hired.
Yeah, I started in January of 93. And we, being the water resources program, had a permanent staff of one. So that was me. But some things had already been set up. We had a small laboratory here. We had established water quality monitoring sites. We had legislation and issues that the tribe was already engrossed in related to hydroelectric and fish contamination and paper mills and water quality issues. And so it was me, and then I had a person that I shared with a fisheries program. So we would kind of share a technician. And then in the summertime, for some of our field sampling, I would usually hire, one field technician. So that's kind of how it started. And, the origins of the program are that the tribe kept kind of going to the state of Maine and saying, like, you should be doing this, you should be doing that. Like, you should be taking, like, there's this spill going on, here's this pollution going on. And before me, there was monitoring going on. And to my predecessor's credit, like, they did a lot of work with the state to try to find out what data are needed in order to improve the water quality here. Like, if the water is good, how can we prove that to you? Or if there's an issue, how can we prove that to you? And so that's the kind of work that was there. And then I just continued on with it. And so there was a cooperative agreement with the state of Maine where the Penobscot Nation would monitor the water quality in the Penobscot River and the tributaries that come into it. And then that would get shared with DEP so that they could use it with regard to management of the Penobscot River and reclassification of the streams and that sort of thing. Anyways, that's kind of how it started. And over the years, it's just evolved in terms of the type of work we do. So we have this ongoing monitoring program. We kind of call it like our baseline monitoring program, where we have, I never know how many sites to say, but between the Penobscot River, tributaries, and lakes and ponds that are on the tribe's trust lands, we have somewhere in the vicinity of 120 or so sites that we go to on a frequent basis. So we have that, and that data gets used to determine whether or not water quality standards are being met. As I said, we have our own laboratory. So a lot of the water samples that we collect are analyzed in our own laboratory. And then in addition to that, anything that has to do with potential threats to the water resources of the tribe, we get involved with. So whether it be contaminants found from discharges that go into the river, airborne pollutants that make their way into fish, a lot of what we do has to do with tribe sustenance rights with regard to fishing and hunting and gathering wild foods. We make sure that they're safe for people to eat or have the data to be able to advise them about how much they should eat. We get involved with licenses for dischargers, any kind of rulemaking or legislation that might involve water quality. We do a lot of work on aquatic insects as indicators of water quality. We collect a lot of information that is not only useful for things like whether standards are being met, but also that can be used by other programs, and whether it be ours or other agencies, the university, on suitability of waters to support certain species of fish or for their scientific projects. We do work on controlling non-point source pollution from going into waters. So that's sort of our regular type of stuff. And then we also do a lot of studies. We're more of a management agency, but we still do some studies on things like before and after dam removals and things like that. So that's kind of our general overall program. We have myself as the water resources overall manager. And, a lot of what I do also involves trying to get the funding and writing the reports and that sort of stuff. And then Angie, who's our planner and data manager. And then we have a lab person, and then we have a person that focuses primarily on non-point source pollution. And then we have a couple of field technicians that are all full-time employees. And then we have interns and seasonal staff as needed.
Is your agreement with the state unusual for a tribe, or is this how a lot of water management happens when there's tribal land?
It's a good question. I mean, I am aware that there are other tribes out there that have some sort of cooperative agreements with their agencies. And Maine is a little bit unique because of the jurisdictional challenges here in Maine with regard to Maine tribes and who has jurisdiction and things like that. So as our program goes, like at the technical level, we get along really well and we share, help each other. DEP helps us out. We help them out. We're able to monitor and give like the Penobscot River a lot more attention than DEP would. We work really well together at kind of that technical level. We collect the data primarily for ourselves, for our own use. But if you want it to be useful in terms of affecting change, then that's why we share it cooperatively.
So, Angie, I'm going to go out on a limb and assume that you're the one who takes all that data and does some analysis for it and looks for patterns and helps understand and craft the story of where water quality is throughout the watershed. Do I have that right?
I would say in general, I'm the person who wrangles is the common phrase. You talk about data, there's a lot of wrangling that goes on. So it is one of the things that often gets talked about is the life cycle of data. So right, it starts out in the field. And when I first came on board, one of the people that Dan was referring to, Jan Paul, she's a Penobscot Nation citizen. She's been here Not as long as Dan, but longer than me in the program. And one of the things I asked her when I first got here, I was like, well, how can I make your job easier, right? What can I do? She's like, can we please go paperless? So she has this great story. She was out in the field near Lincoln once, and it was a windy day. And all her field sheets were clipped down on her clipboard, but the wind came along and away they went. Every single one of them down the river. And she's like, I can't recreate that, right? So with very little concern for her own safety, she pulled up anchor and zoomed down the river. And thankfully she knew she was going well enough. She actually got every single one of those paper field sheets. I was like, okay, well, let's do it, right? So we went to electronic field data entry. So that's where the beginning of the life cycle of data starts, although really the beginning is the river is sharing her data with us. So we go out in the field now, we have electronic forms, and we started this back in 2006, when smartphones were maybe 3 or 4 inches tall and maybe 2 inches wide. So you had to have a little tiny stylus to touch your screen because it was very hard otherwise. We now have forms that start in the field, they come back to the office and you check in your data and you print out what's called the chain of custody to make sure I know I have this many samples and the lab approves that I have this many samples in case something's missing. And then we pre-process our samples in the lab and have electronic forms for that. When we actually analyze the samples that we do in our lab, we actually have forms for that as well, which makes it a ton easier. That's the first step in the wrangling, right? It's one thing to have data, but if you have to then spend all the time writing it down on a piece of paper, and then you have to put it into some electronic format, it reduces the time in half. And then you have to worry far less about typos, and site names are always the same and date times are already automatically stamped and you can read the writing and a lot of parts of a data lifecycle. But it's much easier these days and there's a lot of new software to do this. So, and then we add on the different kinds of things that we do. So we still have to do some data entry forms for other aspects of what we do. And then when you have it in that form, you can check it. You can do calculations really easy. You can say, does this look weird? Like even before you write a report, you got to do all kinds of checking to make sure. All right, is that really supposed to say 200.5 or it's supposed to say 20.5 or what is it? When you see a really weird value, it helps to sort them more easily. You don't have to go back and actually look at somebody's handwriting and say, is that really a decimal point? So it makes it a lot easier. And then when it gets to the point of writing the report, it's much faster to put things together. Dan mentioned earlier reclassification. One of the things that happens in the state relatively frequently, although we went through a bit of a time where it wasn't happening as often, but starting in 2018, but it actually went into 2019, there was a section of the Penobscot River that was classified as C. So there's 4 classifications, AA, which is the highest and most protective, and you can't do anything. You can't have like a paper mill or a wastewater treatment plant dumping into that. And then the next level down is A, B, and then C. So part of the Penobscot, there was still a section left that was classified as C. And in 2018, there came out a request, like if you know that there is any water in the state that is meeting a higher classification, if you have data to prove that, you can submit a proposal to the Department of Environmental Protection to say it should be upgraded. And a side note is that once it's upgraded, part of the Clean Water Act, that's called the anti-degradation rule, that you can't go back, like you can't backslide. So once it's B or A or whatever, you can't go back down. So Clean Water Act is also about goals. Like we don't always want to stay at Class C. So because we actually had 10 years worth of data to support the fact that it was Class B instead of Class C, I mean, I shouldn't say just a few hours, but it took a lot less time because we had our data in a format that was organized and electronic. We could do these summaries and took a lot less time to submit our proposal, get our data together and submit our proposal to say it really should be Class B. And we also were working with some students in Casco Bay High School that year, and they were really interested in what we were doing. They're like, how can we help support what you're doing? And we was like, well, you could write letters of support if you wanted to. So some of the outreach we did, the 52 of those students wrote letters of support for the upgrade that year. And we're happy to say that it got passed. So we've passed a bunch of upgrades in the past, but this was the one that, after having data in a really organized format, made life much simpler. And now we're working on more sort of interactive graphs and maps and things that we can put out on the web so that people can interact with data in a different way than we have been able to in the past.
That's great, because I was just about to ask you, because you have this bank of data, and I'm going to guess you look at it and it's like the Matrix, right? You can read it, you know what it's saying. but not all of us have that capability. Are you now trying to figure out ways to talk about and represent the river and the watershed with data visualization that makes it more coherent to the rest of us?
Yes.
So do you have like a favorite way or an idea of how you want to do that? Or is that what you're trying to figure out now? Like you mentioned maps and you mentioned graphs. And part of the problem for me with data visualization is that because there's so many different options, it's almost overwhelming to know where to start. But because you've been doing this work for so long, maybe you have a sense of like, okay, so this is going to tell us the story initially. Like, have you thought about that, or is that where you're at in the process now?
I have thought about it, and I've been trying to recreate something that I made, probably 5 or 6 years ago at this time in a new software that is better. We'll just say that. We won't use names of software at this point. But the former director of the Department of Natural Resources was like, yeah, I really like that. It's a bit of a challenge. We worked with a group that used to exist, sadly does not. The organization was called Waterwords at Work. Eric used to like to, and I jokingly call it, beat up on people in our profession because we talk shop. And people, like, they don't know the shop talk, right? And so you immediately sort of lose people. So I prefer maps. I really feel like people relate to maps. Usually people go, oh, I know where I live, or I know this particular spot. So they want to zoom in on a particular spot if it's out at a scale where they can't quite see all the detail. I feel like usually people relate to a place. And most people are like, I don't really care necessarily the details of, for example, you should only have this many colonies of bacteria in your water to make it safe. So to plot a graph that says, oh, it's 10 units above, people like, I don't know that that's super engaging. One of the things we're working on is combining it with a map that has the location where it is. So it has a marker on the map. And we calculate whether it is violating its standards. So if you're only supposed to have 236 colonies, we say if it's above that, then we change the color of the marker. And if it has like 10 violations over a 10-year period, it has a darker red marker than one that only had 2 violations. So you have these different color dots on a map. So they're located in a place and they immediately visually tell you, oh, things are probably worse over here than they are over here. And then you can also change the size of the marker. So it's sort of, again, visually. So that's one of the maps. It does have a graph below it. So you can like click on a point and it'll filter out the graph below with all the data. So you can actually see the data. And if you're really interested in it, you can explore it more. Honestly, I usually find maps to be the most appealing way to look at things. Although there is U.S. Geological Survey has a data visualization lab that is actually developing trainings. They do some amazing, super cool visualizations. I don't actually consider myself overly creative when it comes to that, but I'm going to try to learn from them because there's a ton of very interactive ways to visualize data. And when I say interactive, like you can filter out certain data, you can use sliders, there's all kinds of animations that you can use that makes it far more interesting. But honestly, like it's been kind of cool. We've been working with some students in Orono Middle School. We take them out and they actually get to collect the sample, the bacteria sample, collect a water sample. They get to bring it to our lab and they process the sample. It's a very easy hands-on process at this point. IDEX, main company, IDEX, created this amazing way to analyze bacteria. So they get to pre-process it and then we put it in our incubator overnight and then we bring it back to their classroom to count it. And so they're really getting like the whole process and then they actually get the data and then they can make their own plots with data. So it can be a very simple process, but they actually get to choose how to visualize their own data as well. So sometimes it's very actually easy to get people involved in the entire process.
Yeah, one of the challenges we have is that we have sort of a variety of target audiences, right? So if you're trying to appeal to those reclassification requests and to the legislature and EPA and others, like they have formats and data formats that are meaningful and that they follow that you have to do. So there's sort of the science part of us or more technical side. They have to do things a certain way or to write certain reports. But then there's like, well, what does it mean to the average person? And that's where we kind of have to do something that they would be interested in and be meaningful to them.
How much are both of you able to take the information and the data you know, or the data you already have, and foster state-level policies to help the river recover from the past couple hundred years impact that we've done to it? And maybe you don't. My background is policy, so I'm always like, all right, so you have the data, then what? Like I'm betting, because we've talked about it, that you've seen measured improvement in various parts of the watershed for all sorts of different reasons, and the river itself. You said you collect the data for yourself. Are you using it purely to know that things are safe for eating, for example? Or are you also thinking about it from the perspective of how do we further impact the future so that we can get rid of some of the toxicity that's in there?
Well, one of the most important things, which is what Angie spoke about, was the reclassification. So over the years, the data that we collect have been responsible for upgrading, the protections, like from going from like A to double A or C to B or B to A, to get those upgraded for just several hundred miles of waters within the Penobscot watershed. So that means that those waters were either attaining higher water quality, and therefore we kind of locking them in so they can't go backwards. Or it could be that it was reasonable to expect that they were going to be able to meet those standards if certain things happened, like if nutrient criteria are developed or certain uses were allowed or not allowed. And so that has, I think, been one of the most important things, because it's resulted in keeping the river cleaner and making sure that in the future it doesn't go backwards. But we've also used our data in some very specific ways with regard to like contaminants found in fish or in other wild foods. And so being able to show that the levels of dioxin found in fish below such and such a paper mill are really high and exceed safety thresholds, and particularly safety thresholds for Native Americans who have higher fish consumption rates. And we're able to have that data to help show that this is not acceptable. Like just putting a sign up saying don't fish there is not the end game. You need to put process changes in place to drive the levels down so that someday we'll be able to exercise those rights. And not just for tribal people, but for everybody. And one of the ways we've taken that kind of complex contaminant data and kind of translated it into something that is usable for the public are like those fish advisories, or what we developed, call it our wild food brochures, our wild food series. So, we have posters and pamphlets that tell people, depending upon where you're fishing or what your age, or if you're male or female, like what species are the best ones for you to eat if you want to eat fish, and which ones you shouldn't eat and why. But to translate, when we do this project, we end up with all kinds of really thick reports or scientific papers. That's not something that the public is ever going to read. So translating that into like a trifold brochure that is actionable by people is what we try to do. So I hope that answers kind of where you were going with that.
Totally. Yep, totally.
Angie probably has other examples.
Well, I was just thinking that the other aspect of this is it's not always like an active change. It's that, as Dan said earlier, is we are out at a lot of sites. Even if we didn't have a cooperative agreement with Maine DEP, we're still going to be out there, right? So I've often thought us as being watchdogs. And so people knowing that we're out there, even if we get blamed for things that we shouldn't be blamed for, we are still out there monitoring and actually collecting way more data on the Penobscot than anyone else is currently at this time, as far as management wise. Back in 2004 and 2007, in the river, we had what are now more often called harmful algal blooms. So it's actually not an algal species. It was actually cyanobacteria, which can produce some of the same toxins that happen in red tides that close shellfish beds on the coast. And so it started up in Millinocket and went all the way down to the coast. That's like 100 miles worth of river. And often those happen in lakes. Not that it's good, but it's more typical in lakes. But to have that much happening that it like made the river blue-green was crazy. And, they got some regulations put in place and notice violations happened. The fact was that we were going to be out there monitoring it if it was going to continue. So we were out there being present. And so again, even if it's not that it's an active like enforcement action or anything like that, it's just the fact that somebody's out there watching and knowing what's typical and then what isn't typical, what's going on is a huge role. And again, nothing against a state just because there's only so much time. The state's huge. There's a lot of water. So they typically cycle around to different river basins or areas of the state once every 5 years. That's not very frequently. So I think just being out there and having a presence is a very important role for us.
And we've often had people that have contacted us when there is a suspected water quality issue. Somebody sees some nefarious activity going on or something that doesn't look right. They will often contact us and ask us about it. Sometimes they're tribal citizens, but often they're not. Oftentimes they're just other people that are out there on the river or that live next to it. And they'll call and tell us something, and we'll go up and take a look at it and say, yeah, there's a problem here. And just that presence that Angie talked about, we quite often have discovered issues, straight pipes that were dumping into a little stream that, was just raw sewage going in, gasoline spills, oil spills, things like that. So we can be on the scene quickly and collect some information and then contact DEP or whoever the appropriate folks are and get them there to investigate it. We've built trust over the years, a relationship with a lot of these folks, so they know that it's something that should be investigated.
It seems like because you're present and monitoring and are doing such extensive work all the time, you perhaps help head off the idea of death by 1,000 paper cuts and that you're able to get ahead of the game. We should all be so lucky, honestly, with how dependent we are on fresh water. Sampling something once every 5 years is not going to get us there. All right. I think my last question, because otherwise we're going to be talking for hours and I didn't sign you guys up for that. And you didn't sign up for that. Do either one of you have an example of a project or something that was implemented that you think has had one of the most positive impacts on helping the river? And I'm totally putting y'all on the spot here. So if you don't have a specific project, that's fine. But I'm just curious, right? You both have been doing this for a long enough time. You've seen some really interesting things. I'm just curious. You mentioned dam removal, Dan.
Yeah, that's what I would say is the largest impact that I've seen. And that is both from a sort of science standpoint, like, you can measure improvements and things like that, but also just visual. So the fact that before the VZ and Great Works dams were taken out and the bypass channel put in on the Piscataquis River, a lot of these migratory anadromous fish were not able to get past VZ. So we went from having no river herring above VZ to now, like last year, I think we had 4.5 million that came through there. And that's just to that point. So there's other streams that they're going into as well. So that has just been phenomenal to watch visually, to be out on the river and see these huge migrations of, you have river herring, we have salmon, sea lamprey, striped bass, American shad, just all these different species that used to be here and that the tribe historically relied upon for their food, which have been absent. To see those fish coming back is just remarkable. And it's led to other projects with, other smaller removals or fish passageways and culvert replacements and just kind of restoring access to a lot of these places has been phenomenal. And of course, there were some water quality and aquatic insect changes that occurred with that as well that were quite beneficial.
Do you have an add-on, Angie?
I think it's sort of an add-on, in part because, the fact that right now, as of last Friday, we already had 1 million river herring come up over the Milford impoundment. So through the improved fish pass, there's a fish lift that's essentially like a big fish tank. They're attracted to, they swim to the big fish tank, it gets lifted up, they go get dumped out and they can swim up above the dam. The fact that we had millions coming up now, it's happening right now. I remember recently hearing somebody say, talk about like migrations of large animals in Africa, for example. We have this millions of fish. You don't see it, obviously, because it's underwater. Millions of fish coming up the Penobscot River these days, every spring. I guess so the add-on is that we take kids out to see it and we talk about it a lot. So I think the concept of fish consumption and eating wild food safely has been a central point that brings together a lot of issues, science and culture and relationship building. And Jan, coworker I referred to earlier, Jan and I have done a lot of outreach with students from all ages. And we really see some amazing transformations in people. It has been very affected their lives. College students a lot, thinking about what they want to do with their life, have literally said, I think I might change what I want to do based on conversations that we've had with you in classes. This Wednesday, we are taking out, for the third year in a row, we're taking out 7th graders from Orono Middle School. Orono is actually a school to which Indian Island students can go once they leave 8th grade. So they're not in the 7th grade, although they could be if they don't go to Indian Island School. So we're actually taking them out to Blackman Stream. Leonard's Mills is a place over in Bradley that it's a logging museum, but they have this neat stream. Blackman Stream comes up and there are just thousands of alewives in this stream. And last year, actually, they had a lot of fun because they were in the river, in the fish ladder, literally catching alewives, river herring with their hands. There's that many of them. So we have about 5 stations. This year, we're going to have 5. Last year, we had 4. But where they actually catch river herring and they measure them, they get their sex, they look about scales and otoliths. But we're also having them use GoPro cameras to capture video of the fish coming up, as well as underwater drones with little virtual reality goggles. And so we're talking about Penobscot culture and how it's connected to the natural world and language. This year, we're going to make an offering of tobacco to the river for the students. That's the first year we're doing that. So the science provides this framework to build relationship with other people. And as Jan always says, you're not probably going to harm somebody that you know as a person. So getting Penobscot culture to be understood and getting to know Penobscot people has made a huge difference. So it's not like an implementation project, but I really think that that relationship building makes a big difference. We also went to Brewer Community School for the 2nd year in a row, and we talked to 3rd graders. Really big difference from what we usually do. And Dan did a great job talking about the river and saying that the river is considered a relative. And there's actually a video that folks can watch online called This River is My Relative, made by Sunlight Media Collective. And then Jan did some talking and referred to the river as she. And then when it went back to Dan had asked the best question ever. He said, so did anybody notice anything about what Jan just said? And this little girl on the front raises her hand. She's like, yeah, she referred to the river as she. And Dan's does that make sense? Does that make sense why she would do that? And she's like, totally got it. She goes, of course. She says, you said that the river, they feel like the river is their relative. And of course, the relative has to have a gender. Jan and I both nearly cried because we just think 3rd graders get it. And so with all this science, right, and trying to do outreach, I feel like building those relationships, I feel like that's going to be the thing that keeps things going, right? We can do a lot of science. We got to all understand that Penobscot Nation's not trying to put people out of business or do bad things. Like Dan said earlier, it's all the fish consumption activities that we protect for, making fish clean enough for Penobscot people to eat. Well, that actually means everybody else can eat them too. So there's no separation. It's just not the case. And in order to get that sense out there, we can all work a lot better together if we build a different relationship.
Yeah, and getting people out there to experience that is just so important because otherwise they have no connection to it. It's happening now and most people don't know it. They drive by the stream and you don't see the fish, so unless you're down right in the stream and then you see it and it's wow. And it transforms people into caring about something. Not that they didn't care about it, but they just never really thought about it. And so if you're experiencing some of that, then you develop that relationship and care about it.
It makes me think of the recent eclipse that we had, which made people think about the sun and the moon in ways that they had never thought of it. And then just this past weekend, right, with the Northern Lights. Oftentimes I'm on many quests, but one of my quests is to have people recognize that science is a critical part of culture. And in this case, it seems to me that science can be used as almost a gateway for people who don't understand different cultural aspects. But if they get data and science, we start talking about water, and then you can use that to get your way in. It's all intertwined. I appreciate both of your time on this and your patience with me as I got this rescheduled so we could talk. Even more than that, I deeply appreciate your work. It was pretty great to listen to both of you talk about rivers in the way you did. And you, again, intertwined right in your introduction when you were talking about how you got into it. You both had this really cool approach talking about waters and rivers. It was great to build off of that and have this conversation. I really appreciate it.
Well, thank you for the opportunity, Kate.
Yeah, it was great to meet you at the museum and great to have this chance to follow up. And I encourage people, they could go up to Milford. There's a little kiosk outside of the Milford Impoundment. They have a camera on the viewing window so you can watch all these fish go by during this time of year. So I encourage people to go up to see it. So thanks for this opportunity, Kate.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Lozelle. The Discover Maine theme was composed and performed by Nick Parker.